Okay, 8th graders, today we're going to continue talking about functions, but before we keep going, I want to do a little concept review up here. Let's review what proportional relationships are, or look like, and what non-proportional looks like. So let's look at what it looks like with a graph and with an equation. So a proportional graph will always go through the origin. The 0, 0 will always go through the origin. A non-proportional graph will start or go through any other point on the y, just not the origin. A proportional equation will be in the form of y equals mx or y equals kx. Remember that m stands for slope, k stands for the constant of proportionality. They're pretty much the same thing. We just don't add or subtract anything here because it starts at 0. So we just need the slope and the x to write the equation. Non-proportional will usually take y equals mx plus b, where b is that y-intercept, so it tells you where it goes through on the y-axis, okay? So let's go ahead and look at a linear equation, which we kind of reviewed a little bit here for its non-proportional. If the graph of an equation is a line in y equals mx plus b form, so where you have the slope and the y-intercept, a linear function is a straight line graph as long as it's not vertical. So let's draw a couple of examples here so that we know what it looks like. So let's draw this one. This is a straight line, so that does count as a linear function. Let's look at another one. This is again a straight line and it's horizontal. So remember the x's are only happening once. So that is a function. And we kind of mentioned this one yesterday. Let's see if you guys remember. The straight vertical line keeps repeating that same x for that point. So that is not a function. So not a linear function, okay? So just make sure that we know that the linear function is a straight line as long as it is not vertical. Okay, proportional functions, same as the proportional relationship up here, always goes through the origin. So you're going to notice that a lot of this information is familiar. We're pretty much reviewing our previous chapters. So now how do we know if a function is proportional? If we have a table and we see the point 0, 0, remember that that means the origin, and it has a constant slope. What do I mean by constant slope? It's that constant of proportionality. So you can check the y divided by the x, and if it's the same every time, then it is proportional. Whenever we have an equation, we know that the function is proportional if it's in the form y equals mx. I know there's like a little minus sign there. Don't worry too much about that. That's just a typo. So we can just kind of recopy it on the top here. I'm sorry about that. You're following the same format up here. No b, because remember it has to go through the origin. And the x can only have an exponent of 1. So no x squared, no x to the third, no little funny numbers up here in the exponent for the x. Just the x by itself there. And for the graph, if the graph goes through the origin. So pretty much the relationship between proportional and non-proportional, we're just applying it to functions now, and the same rules apply. So let's go ahead, and we need to figure out here if it is nonlinear, linear, proportional, or non-proportional. So let's go ahead and look at this. And it is a curve, so looking at the fact that it's a curve and not a straight line, we know that it is not linear. Now if we look at the other ones, we see that this one is a straight line and it does go through the origin. So that is a linear relationship. And since it goes through the origin, it is proportional. Now let's go ahead and look at the third example. Sorry. Now I do see that it's a straight line, so that is linear. But it doesn't go through the origin. The origin is right down here. It's actually intercepting at 5, so it is non-proportional. There we go. So now let's go ahead and look at the equations. I have here that this equation is y equals, I have a number, and I have another number next to the x. So let's go ahead and try to switch this up so that it says, so that it's in y equals mx plus b format. So y equals, see the number that's here with the x, we're going to put it here so that we know how to read it, and this is plus 1. So this does have a y-intercept of 1. So we do know that it's non-proportional, but it is a linear equation. Now let's go ahead and look at this one. 4x equals 12. Now that one looks kind of weird because it doesn't have y equals, but we can go ahead and solve for x. We know that if we divide by 4, I would get x equals 3. That is actually, if you guys remember, a horizontal line. So 1, 2, 3. It's a horizontal line. So that is a straight line, so it is linear. Let's just kind of write it down here. There it is. Now, there is another way in which you could check it. Remember that you guys do have graphing calculators for a reason. They help you out. They can help you identify whether it's a straight line or not. So let's double check the first two before we get into the other two. So make sure that you hit y equals. Make sure that everything is clear here. And you can either type the first version or the second version. Either one is fine. I'm going to type the rewritten one. Negative 2x button right here next to alpha plus 1. And when you click on graph, we do see that it's a straight line. It's a linear equation. So we're good to go on that one. We were correct. Now this one, it's x equals 3. So that is not an option here because all of my lines start with y equals. We actually went over this on our last chapter. It was on a white foldable, so you can refer to that one. But y equals 3 will look like this. So that's still linear. Remember? Still linear. Okay, now let's go ahead and do this one because this one does have a little exponent there. So we might not be sure. So type it in just like you see it. 6x squared minus 2. And then you're going to hit graph. And that is not a straight line. That looks just like this one. So that is not linear. And now let's go ahead and look at this one. This one has the y in this spot, but I do have, here's the slope with the x, and then here's the y-intercept. So again, we can go ahead and redo this in y equals mx plus b format. So it'll be y equals mx is this, 8x plus negative 1, or minus 1. So again, I do know that it's y equals mx plus b, so I do automatically know that that's linear because that's my linear equation. See up here? But if you had any doubts, and if you forget, clear it and go ahead and type it in. 8x minus 1. You can go ahead and graph it, and there it is. It is linear. So we have basically just reviewed what is linear, what is nonlinear, proportional, and non-proportional. So again, just kind of a little bit of a review of material that we used before. So let's go ahead and go to the next page for word problems. Okay. Juanita usually spends $3 more than twice her transportation cost on groceries. If X is the amount she spends on transportation and Y is the amount she spends on groceries, the amount she spends on groceries can be represented by this equation. So they actually went ahead and gave you the equation. If they don't, you know that it's 3 more than, which that means plus, twice. Twice means that you're multiplying, so that's where the 2x comes from. So if not, we could have gotten it from the word problem. But they actually do give you the equation, so that's good to go. Now, just from looking at it, we can answer some of these questions. Is the relationship between x and y linear? Is it going to make a straight line? Well, let's see. Is this an y equals mx plus b format? I think so. And if you're not sure, you can always go ahead and graph it. Clear it. Y equals 2x plus 3. Go ahead and hit graph. And there it is, a straight line. So, yes, it is linear. Now, is it proportional? Remember that proportional always starts at the origin. Where would this line start? It starts at 3. And if you're not sure, you can look here. See, it's not going through the origin. It's starting here at the 3. So it is non-proportional crosses y-axis at 3. Remember, we can just tell just by looking at the equation. Now for the next one, we have done this before. We are going to use this equation to solve a problem. It's asking us how much Juanita spent on groceries if she spent $30 on transportation. So I know that the 30 goes with transportation. And I know the x is transportation. So I'm going to go ahead and recopy the equation that they give me. And since 30 goes with the x and transportation is x, that 30, it's going to be plugged into that x. So y equals 2 times 30 plus 3. And the easy way to solve this is you literally type this in your calculator. 2 times 30 plus 3. And go ahead and hit enter. And it gives you how much she spent on groceries. She spent $63 on groceries. Okay. Then for the next problem, the amount of water in a tank being filled, so we know it's positive, is represented by the equation y equals 20x, where y is the number of gallons in the tank after x minutes. So it's given me the equation already, and it wants me to use that equation to complete the values here. So I know that the y is the 20 multiplied by whatever the x is. So 20 times whatever the x is, and in this case it's 0. So 20 times 0, which is 0. If not, no time has passed, then there is no water on that tank. Let's do this one. 20 times what my x value is. 20 times 1 is 20. Let's do the same thing again. 20 times whatever the x value is, in this case is 2. So that'll be 40. And I can do this one. 20 times what my x value is, which gives me 80. Now, by looking at the graph, we can pretty much figure it out what this number is. If it had harder numbers, what you do is you just divide. Since we're multiplying to get to the y, then you just divide to get to the x. So 60 divided by 3, by 20, sorry. We're multiplying by 20, so we're dividing by 20. Sorry about that. 60 divided by 20, that's where you get the 3. So just in case you ever get harder numbers, remember that you multiply to get to the y, divide to get to the x. So that's how we complete the table, by using the graph, the equation. Now we need to go ahead and sketch the graph of the equation. So these are my points. My first point is 0 on the x, 0 on the y. Start right there. My next point is 1 on the x, 20 on the y. 1x, 20y. My next point is 2 on the x, 40 on the y. 2 on the x, 40 on the y. Next is 360, and the next is 480. Okay, so use your graph to predict the amount of water in the tank after 6 minutes. So let's go ahead and predict. I know that 6 minutes will be here, right? And it seems to just kind of see how it does the same little hops with slope. 2 and 2, 2 and 2, 2 and 2, 2 and 2. So keep going. 2 and 2, 2 and 2. So here's what I want, 6 minutes. So in 6 minutes, notice how this is going by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So we will have 120 gallons after 6 minutes. If we didn't use the graph, you can also use the equation. We know that y equals 20x, y equals, and it's after 6 minutes, so 20 times 6. And 20 times 6 will give you 120 as well. Now we need to explain how we know whether the relationship between x and y is linear or nonlinear. You can just go for the easy explanation, which is the graph makes a straight line. But we also know that it is a constant rate because the rate is 20. Constant rate of 20. And there we have it. That is our lesson for today. So you guys can look at the next video if you need help getting the homework started.